Hello. Today we're going to talk about 2.6 families of functions. Okay, so we did the absolute value function in the last section, and so hopefully you remember the parent function and all of the transformations. Well, what's awesome about that is that if you memorized those, we can actually apply those same transformations to every other type of function out there. Starting with, well, we can start with linear. Okay, so notice linear only has a and k. Well, because if I added an h, it would look kind of silly. So if you think about it, that would be a times x minus h plus k. So we would distribute that a, and then we would actually be able to combine that last part. So that's why we don't really mess with an h. Okay, this is linear. We're going to leave it as in slope-intercept form. Okay. So yeah, that was a little weird, but you can still apply the transformations of a and k to it. All right, I can always bump that up to do quadratics, which are x squared. All right, so there has an a, h, and k. Notice the h is inside of the squared, so it's right next to the x. And then we can take it further and do any kind of polynomial. So we can do cubics, quartics, quintics, all sorts of things, anything raised to whatever power. Okay, so cubic is the one we're probably, or the one you're going to see most often. So x cubed, and then a 3 there. Again, the h is right next to the x. Okay, we can even take it further and apply it to trig functions, sine, cosine, and tangent. Okay, so even though you probably have no idea what those graphs look like, I can still apply the same idea with transformations, a, h, and k. I can still tell what's going to happen from the original function. Okay? Well, these were the basic three transformations, a, h, and k. However, there is a b, the seldom talked about b. It's inside of your function. Okay, so it's inside next to the x. All right, but it's still inside the absolute value or inside the part being squared or cubed or whatever, or sine. So the things on the outside, so let's just focus on the a and the k, that has to do with the up and down, okay, the vertical movements, okay? A, if you remember, if that is negative, then it's reflected over the x-axis. Okay, if you remember, if you just take the number a, if it is greater than 1, then it's a vertical stretch. If the a is less than 1, okay, just the absolute value of it, so between 0 and 1, then that's when you have a vertical compression. And k was when you then you move up or down. Okay? Now, the inside B and H are going to do the same types of movements, okay, except it's going to be your horizontal, so left and right movements, okay? So we can still say the same idea as up here. So when B is negative, then there's a reflection, then reflected over the y-axis. Okay, so that's flipping it like a book, or folding it in half like a book. Then if, okay, the next part, when we talk about B being greater than 1 and when B is less than 1, we'll get back. Let me first talk about H. That might make it easier. Okay, so if you remember, H does the left and right, but it does the opposite of what you think. So if this is negative right here, you're going to move to the right. And if that was positive, you're going to move to the left. So this does the opposite of what you would think. So if b is bigger than 1, I'm not going to stretch it. I'm going to compress it. But it's going to be a horizontal compression. If b is less than 1, okay, we would think that's a compression, but nope, does the opposite of what I would imagine. So then it's a horizontal stretch. Okay, so let's do some examples. So the first one, we're going to the first few problems that we're going to do is just describing the transformation. So hopefully we recognize that this is linear. Okay, so our movements are going to just be, we're multiplying, that's an A movement, and when we add at the end, on the outside, that's a K movement. So, sorry, let me get rid of that. Then here, so A is 2, so since A is 2, so A is 2, sorry, I had to fix my color. All right, we know it's going to have a stretch, and we know the K is 3, so that's going to be an up movement. So how we write that is we say a vertical stretch by a factor of 2, and up 3. Next one. So this one is x to the 6th. So in our, I guess, general form, you can write this like that. So the only thing we have is on the end, we're adding a k. So that's at the end of our equation. So since k is 2, this is going to go up by 2. You would say up by 2 units, but I'm perfectly fine with you guys saying like up 3. Okay, that's fine too. Okay, so this one, we have a cubic. So in general form, you would have this. So since the -1 is on the inside, that's a left or right movement. So h is 1, you take the opposite. So since h is 1, that's a right movement. So we're going to go right 1. And these are your answers. Okay, so why don't we try a few more? You knew I was going to say that. All right, so for this one, this is linear. This is multiplying, so that's an A movement. So since it's negative, we know it's going to reflect over the x-axis. And then we also know since it's 3, that is bigger than 1, since 3 is bigger than 1, we know it's going to have a vertical stretch by a factor of 2. I'm sorry, by a factor of 3. A factor of 3. This was supposed to be a semicolon, not a J, just so you guys know. Okay. Then number 5, okay? So this is multiplying, it's out front, so that's another A movement. So since that is bigger than 1, all we need to say is a vertical stretch. I'm fine with you shortening vertical to vert. All right, so it's a vertical stretch by a factor of 4. Notice how I'm putting the factor is just the A value. It's not including the negative. Like on that last one, it was by a factor of 3. Okay, then number 6. So we have an A value and we have an H value. So since our A value is 0.5 is smaller than 1, then it's going to be a vertical compression. by a factor of 1/2, or 0.5. Okay. We're also going to have a movement. We're going to go right 1. There you have it. All right. Let's do some more, of course. So let's see. Hopefully number 7 is an easy one. Since that's an x squared, there is no movements, right? This would be a parentheses x minus h if we're just doing our basic ones. Okay, so here we don't have any movements. So this would be none because it's the parent function. It's one of the originals. Okay. Number 8. So for here, now I have a b in my mix. So now I need to rewrite this. I need to make sure that inside I put the b separate. So I'm going to put that -1 out front. So if I factor out that -1, well then this has to be +2. -2 divided by -1 is +2. Because if I would distribute, well then I would get -x minus 2. So you have to factor out the b value. So now we have a is 4, we have b is -1, and we have h is -2. So the a gives me a vertical, not compression, silly me. So it's a vertical stretch by 4. Then the negative b value tells me there's a reflection over the y-axis. Remember that one's not going up and down. So we're flipping over the y-axis, so that's like having my hands up and then touching my toes. So I'm bending in half like that. Okay. Then the h is -2, so we're going to go left 2. And number 9. Number 9, that's on the outside, so that's a k movement. So all we have is k, so we're just going down by 4. And that's it for these 3. Practice some more. All right. And now I'm just going to walk through them again. Keep doing what I'm doing. So for number 10, this is multiplying, so that's an a value. It's not on the inside. If that was a b value, I would have had parentheses like this. But I don't, so that's not a b. That's on the outside. It's an a value. Okay, think of it like this. So a is 2, and k is -3 because it's on the outside. So now we have a vertical stretch. Ooh, that's supposed to be an h. And a vertical stretch by 2, and we're going to go down 3. That's it. Number 11, we have a lot going on. Notice you do have a b value, so you've got to factor it out. So leave that a outside, then this becomes x plus 1/2. Because 2 times 1/2 is 1. So you divide it out. Okay? So this means a is -2.9, b is 2, and h is -1/2. So this is going to have a lot. Since a is negative, it's going to reflect over the x-axis. That is a terrible over. Okay. Over x-axis. Since 2.9 is bigger than 1, it's going to be a vertical stretch by 2.9. B is 2, so it's going to have a horizontal. And since b is 2, remember it's going to do the opposite of what you think. So it's not a stretch, it's a horizontal compression. And we're not going to say by 2 because that doesn't really make sense, right? A horizontal compression by 2. So how we say it is we do 1 over whatever the b value is. So since it's 2, we're going to say it's a horizontal compression by 1/2. Okay? Because you're describing the scaling effect horizontally. And when you say the scale is 2, that's actually, it's doing the opposite. You're describing it in words, okay? But mathematically, it represents a different number, okay? So then the h being negative 1/2, that means we're going to go left 1/2. Okay, yeah, I know that one had a lot. All right, and the last one, that's multiplying on the outside, so 0.9 is an a value, and 1 is your k value. So that's less than 1, so we're going to have a vertical compression by 0.9, and we're going to go up 1. And that's the answer for those. Okay, so now we're going to work backwards. We're starting with this equation, okay, our absolute value. So if you need to think of it, put the equation, so the a, put your b, plus k. But of course that's absolute value, so don't really know what I'm doing there. I need to make sure I put absolute value bars. Okay. So we're going to have a horizontal stretch by a factor of 7. Okay. So let's see. So that means our b is going to be 1 over 7, right? We do the opposite with the horizontal. And it's going to be down 12, so that means k must be negative 12. So our equation is going to be y equals the absolute value of 1/7 x minus 12. For number 14, the translation up 4 units, so k is 4, and right is 7, so h is 7. So when we plug this in, we get this. No a and no b. Well, a and b would be 1. Sorry, I should make that more clear. So no change in a or b. So then for this one, we've got a vertical compression. So that's our a value is 1/5. So all we have to do here is multiply on the outside. And then here, number 16, we go 2 units up. So k is 2. If I can read, silly me. Trying to rush through it. Okay, so left 2 units, so h is going to be negative 2. K is going to be 1. And a reflection over the y-axis, so that means b has to be negative 1. So we write our equation, we get y equals negative 1 x plus 2 and then plus 1. Or we can write this, I was trying to make that or look better, but it just didn't. Okay, so or you can write it as y equals negative x minus 2 plus 1. Okay, let's do some more practice. Alright, so let's see, I can tell you the biggest mistake here is people don't pay attention to the original function. We're not doing absolute value anymore, now it's a quadratic. So think about how your transformations would look. Your h and your b would happen inside of the main thing here, which is squaring. So that's happening inside the square. The a and the k happen on the outside. So 17, we have a vertical stretch, so A is 9, and a reflection over the x-axis, so that means A is negative. So our equation is going to be y equals negative 9 absolute value of x. See how that looks confusing? That's a 9. Anyway, 18, horizontal compression. So that's a B value by a factor of 0.8. So 1 over 0.8. So let's see, we get 5 over 4, which is 1.2. Okay. Nope, I lied. 2.5. Okay. So then let's see, in a translation of up 1, so K is 1. So our equation, did I really just sit there and spend that whole time talking about making sure you put x squared and then just do absolute value? Holy moly. I'm being real silly. Okay, let's try that one again. So this needs to be just an x squared. Okay, sorry about that. Back to this one. So B is on the inside, so we're going to have 1.25 x squared plus 1. Okay. 19, we're going to go down 2 units. That's a K movement. Over the y-axis. Okay, y-axis is a B movement, so B is negative. So here we're going to have negative x squared plus 2. Vertical stretch, so that's an A movement, and left 10. So our equation is going to be x minus 10 squared, not plus 4, silly me. The A value is 4. There we go. And there's your final answer. All right, so that's it for families of functions. If you have any questions, come see me in class.